Today we're going to cover host-to-host communication with Microsoft TCP/IP. So we're going to talk about what TCP/IP parameters have to be filled in to communicate, and then how each of these parameters come into play as we communicate from one host to another on a TCP/IP network. Okay, the first thing we talk about is the IP address. Now your TCP/IP address uniquely identifies your particular device on the TCP/IP network. A computer requires a TCP/IP address, and more specifically, every network adapter, or every interface in the computer requires a TCP/IP address. Every interface in the router requires an IP address. An interface in printers or any other device that you want to communicate with on a TCP/IP network requires a specific, unique TCP/IP address. Now, the format of an IP address is 4 what they call octets. Now, when you're creating an IP address, the last number, which ends up being your final number of your address, has to be between 1 and 254. The last number of 0 identifies that actual network segment, and the last number of 255 is the broadcast address. Communication sent to the 255 address will be sent to all hosts on that TCP/IP network segment. Okay, so we've got an IP address. In our case, it's 192.168.100.50. Another parameter that you have to fill in is the subnet mask. Now, what the subnet mask does is it tells you what the breakout between the network and the host is for your particular TCP/IP address. So with this address here, part of it identifies the actual network segment that I'm on. So a network segment would be anything on my side of the router. Here's our router interface. Everything out here is considered my network segment. So part of this TCP/IP address identifies the network segment. Part of it identifies which host on that network segment am I. So an analogy I like to think about with network versus host of an IP address is your address at home. So you've got a street that you live on, that would be your network segment, and you've got a street number. So if I live on Main Street, then Main Street is my network segment. If I am 503 Main Street, then 503 would be my host address, the host on that network segment. Okay, the subnet mask we're going to cover in another CBT nugget, how to create a subnet mask, how to modify, and how to convert from binary to decimal and back again. But for now, let's just talk about real quick, basically, how it identifies the network versus the host. So, with a subnet mask of 255.255.255.0, what we're doing is we're developing a breakout of network to host. A subnet mask is going to be anything from 0 to 255 because, again, it's 8 binary digits. And based on how many binary digits you're using for your subnet mask, that's going to determine what your breakout between the network and the host is. We're just going to talk about the default subnet masks, which only use 0 and 255 for this scenario. So if I have 255, 255, 255, I'm using all of these bits to say, this is my network. With 0, I'm using none of those bits that identifies my host. If I were to set up a subnet mask of 255.255.0.0, then my network to host separation would become right here. So now I'm on the 192.168 network. And all of these numbers are going to identify my hosts. So now my host can go from 0.1 to the end of the range. So we've got 64,000 hosts that we can have on each one of these network segments because we've got 192.168 0.1, 0.2, 1.1, 1.2, 2.1, 2.2, etc. So quite a bit of hosts on that one network segment. Typically, network administrators will want to make their segments smaller so that they can have smaller collision domains, so that they can segment their traffic a little bit, and try to keep things on different sides of the router so that you can have a more efficient network. Okay, so in our scenario here, we're going to start off with a subnet mask of 255.255.255.0, which means that the network that I exist on is the 192.168.100 network. The host that I am within that network is 50.